Edwards Air Force Base, high in California's Mojave Desert. An elite breed of aviator prepares to embark on an exploration of the frontiers of flight. These pilots routinely soar higher, race faster, fly closer to the edge than anyone else on Earth. Their task is a simple one. Take an unknown machine, steer it into the sky, and bring it back in one piece. And in so doing, make the unknown understood. Whenever people take to the air, a fighter pilot roaring aloft, a business traveler zipping across the country, the astronauts streaking into space, we all ride in the wake of those who went first, the men and women who paid for each step skyward with courage, perseverance, and sometimes their lives, the test pilots.
The need for test pilots is fundamental. Despite years of planning, simulation, and the most detailed calculations of aircraft designers and engineers, the underlying question remains, will it fly? It's this element of uncertainty that the professional must face with each and every flight. Someone has to sit at the control and assume the risks. Sometimes they're successful. On other occasions, the best laid plans come up short. But the pilot never undertakes this challenge alone. The professional test pilot is a member of a highly skilled team. Whether testing an experimental bomber for the military or putting the latest commercial airliner through safety evaluations, pilots and flight test engineers, designers, mechanics, analysts, ground crewmen, and technicians of all sorts contribute to a successful flight test program. Working under extreme conditions, this cooperation is essential. With today's complex multi-million-dollar aircraft, it would be impossible for a single individual to go it alone. However, this was not always the case. With the flip of a coin, Orville Wright gained the distinction of being the first test pilot, having designed and constructed the world's first airplane with his brother Wilbur. The Wrights set about proving that it worked. They had no one to teach them how to fly. They invented test piloting as they went along. Most early test pilots, like the Wright brothers, designed and built their own flying machines. Yet unlike the Wrights, many of these plucky pioneers had more courage than know-how. The specter of the unknown invested each flight with an element of suspense. Failures were all too frequent. But for the successful test pilot, a safe return to Earth guaranteed an unmatched sense of exhilaration and accomplishment. The coming of the Great War saw the proliferation of the aeroplane. No longer the province of intrepid entrepreneurs. Aviation was big business. Factories churned out the latest advances in aerodynamic science. And with the fate of nations hanging in the balance, a growing number of determined individuals, test pilots, devoted their energies to pushing each plane faster, higher, farther. After the armistice, an entire generation of experienced aviators returned from the battlefield. The military, eager to explore the limits of its new machines, found a ready pool of willing test pilots. In 1919, Navy seaplanes commanded by Albert Reed made the first successful crossing of the Atlantic. Army test pilots John McCready and Oakley Kelly tried to be the first to fly non-stop from coast to coast. In a modified Fokker T-2, McCready and Kelly took off from New York on their third attempt at transcontinental flight. Despite headwinds, a lack of navigational aids, and some close scrapes with the mountains of New Mexico, McCready and Kelly touched down in San Diego nearly 27 hours later. The nation was amazed. Army flyers Lowell Smith and J.P. Richter pioneered new techniques for in-flight refueling and established an endurance record of 37 hours and 15 minutes. But for Smith, the biggest challenge was yet to come. As part of a team of 8 airmen, 4 pilots and 4 mechanics, Smith embarked on an unprecedented circumnavigation of the globe. Despite the loss of 2 planes, the Army test pilots completed their 5-month odyssey and returned to a rousing welcome. Their 26,000-mile journey demonstrated the airplane's ability to go the distance. Even as airmen proved how far an airplane could go, for other flyers the question was, how fast? Air races sprang up around the country, offering test pilots and aircraft builders the opportunity to probe the limits of speed. Speedsters like the Navy's Al Williams possessed a unique enthusiasm for unfettered exploration. This willingness to experiment propelled Williams to some of his greatest work. His pioneering studies of inverted flight, for example, represented one facet of his knack for innovation. But Williams' penchant for experimentation led him inevitably to racing. More than once, Williams took off in pursuit of a world's record. With a top speed of 266 miles per hour over a measured straightaway, Williams' 1923 mark made him the fastest man alive. Williams then challenged the best flyers of his day in the 1923 Pulitzer Air Race and guided his Curtiss racer around the pylons in record time. Throughout the 20s, Al Williams' singular determination propelled him to the top. Equally driven, Jacqueline Cochran had a distinguished career as a racer and test pilot. She beat a field of the best flyers, male and female, in the 1938 Bendix Transcontinental Race and was later the first woman to fly faster than the speed of sound. For Jackie Cochran, like her colleagues, speed was an obsession.
I have maintained ever since that I've been flying that there's only one reason for flying, and that is speed.
Roscoe Turner, one of the more flamboyant figures of air racing, cut a jaunty swath through the record books during racing's golden era. For millions of air race aficionados, this self-proclaimed colonel in the Nevada Air Force came to epitomize the swaggering mystique of the test piloting hero. But Turner's devil-may-care attitude belied his meticulous planning and skillful airmanship. The only 3-time winner of the prestigious Thompson Trophy, the Indy 500 of air racing, Turner pushed his Pratt & Whitney engineers to deliver more and more horsepower. In untested designs, he flew all out, sometimes losing but winning more often than not. In the world of air racing, Roscoe Turner elevated the pursuit of speed to a new art. But for Jimmy Doolittle, it was pure science. Perhaps the most famous flyer of his time, Doolittle achieved celebrity with a series of record-setting flights and air race victories. The 1925 Schneider Cup, a contest for seaplanes, was typical of these test piloting spectator events. Representing the cutting edge of technology, men and machines came from all over the world to compete in this public aeronautic laboratory. More than just drivers, the pilots functioned as scientists as well, juggling 1,000 variables while guiding their one-of-a-kind airplanes around the racecourse. Doolittle won the Cup by averaging 232 miles per hour, the fastest a seaplane had ever flown. The consummate flyer, Doolittle set milestones no other could match and assembled a scrapbook chock full of aviation accomplishments. In 1932, Doolittle prepared to enter the Thompson Trophy contest at the National Air Races. He was flying the GB Racer, a pudgy barrel of a plane notorious for its deadly stability problems. Fans and the press expected the worst, but Doolittle steered his squat ship around the course without incident, flashing across the finish line in record time. His victory, however, did nothing to diminish his growing belief that there were less dangerous ways to advance the science of aviation. Retiring from racing, he put his training to use solving aviation problems of the day. Unique among his peers, Doolittle had earned one of the first PhDs in aeronautical engineering, and in collaboration with Elmer Sperry, he tackled the problem of flying at night or in poor visibility.
I made the first blind flight, first completely blind flight, taking off under a hood, flying a prescribed course, and landing back under the hood without ever having seen out of the airplane. This doesn't sound very important now, but out of that came two instruments, the artificial horizon, the directional gyro, that are today standard equipment on every commercial airplane and every combat military airplane.
With a record of accomplishment unmatched in aviation, Doolittle ranked as one of the fastest flyers of his time. It remained for others to set new distance marks. A virtual unknown and former airmail flyer, Charles Lindbergh took a scientific approach in planning the flight of the decade. A trained test pilot, Lindbergh provided the Ryan Aircraft Company with the specifications for a long-range monoplane designed to cross the vast Atlantic. After a test flight and some final adjustments, Lindbergh flew the plane, which he had dubbed Spirit of St. Louis, directly to New York. There he met other challengers, including Admiral Richard Byrd, who were waiting for a break in the weather. The attempt at the first solo transatlantic crossing was to be the plane's third flight. On May 20th, having removed his radio and parachute to conserve weight, Lindbergh prepared to cross the Atlantic in a tiny, untried plane with only a thermos of coffee and 5 sandwiches to sustain him. In the truest tradition of the test pilot, Lindbergh set off alone to see how far one man could fly. After 33 grueling hours, fighting fatigue and a growing disorientation, Lindbergh touched down at Orly Airport outside Paris, setting off a frenzied celebration unsurpassed in the history of flight. The parades and speeches continued unabated on both sides of the Atlantic, and test pilot Charles Lindbergh became the most famous flyer of his time. Following Lindbergh's record flight, veteran aviator Wiley Post made history by completing the first solo flight around the world in 1933. His next adventure was in the realm of high flight. Working with the B.F. Goodrich Company, Post devised an ingenious pressurized flying suit that could be inflated to maintain normal atmospheric pressure on the pilot, even in the rarefied air of the jet stream. The world's first aviation pressure suit, a forerunner of the astronaut spacesuits, enabled Wiley Post to fly above the crowd and into aviation history. By the mid-30s, the lure of test piloting was proving irresistible, even to those already rich and famous.
Another record falls. Colonel Roscoe Turner will have to try again. In September 1934, he reached New York with slightly over 10 hours flying time for a coast-to-coast flight. But Howard Hughes, young oil magnate and motion picture producer, has done the incredible, flying across the nation in 9.5 hours. A novel retractable landing gear for minimizing wind resistance and increasing speed last September helped this ship to set a world's land plane record of 352 miles an hour. And now, in a special mail plane with a 2-speed supercharger, Hughes smashes all transcontinental marks. And here he is.
Well, I just arrived from Los Angeles, leaving there at 3:15 Eastern Standard Time and arriving here at 12:42 and 10 seconds, making 9 hours and 27 minutes for the hop. The flight was made at 18,000 feet, using oxygen all the way.
Though Hughes had no need to take his untried designs aloft, he insisted on testing his own prototypes. Undeterred by several close calls, he continued to fly the newest planes and the latest technology, smashing records along the way.
The giant flying laboratory of Howard Hughes makes its tune-up flight preparatory to hopping off for Paris. Over the skyscraper canyons of Lower Manhattan roars the plane that is to cut Lindbergh's 1927 record time in half. As evening falls, the millionaire sportsman and his crew of 4 start one of the greatest adventures of the century, a 3,600-mile non-stop flight.
They've landed!
In contrast to the public adulation lavished upon such luminaries as Hughes, a growing network of professional test pilots labored in solitude and obscurity. Working for the fledgling aircraft companies of the 20s and 30s, these hardy souls put their lives on the line, day in and day out. An especially intimidating assignment was the terminal velocity dive. Take the plane as high as it will go, point it straight down, and see if the wings stay on. It was dangerous work. The jobs were scarce in the days of the Great Depression, and it was a chance for a man to send a little money home to his family. One freelance pilot, a sometime journalist named Jimmy Collins, summed up his dilemma as a choice between death in the afternoon or reunion in Oklahoma. In eerie anticipation of his own fate, Collins wrote, "The cold but vibrant fuselage was the last thing to feel my warm and living flesh." It proved to be his epitaph, and that of more than one brave test pilot.
As the 30s wore on and wooden biplanes gave way to more streamlined metal designs, techniques such as the terminal velocity dive were phased out in favor of less hazardous flight test procedures. The aircraft industry had come to rely on more sophisticated analysis, aided by a variety of new measuring devices. Seat-of-the-pants flight testing was becoming a thing of the past. Military and civilian leaders realized that the truly valuable test pilot was one who could ferret out deficiencies, make recommendations, and express himself in the language of the engineer. Such exceptional airmen are created, not born. And soon, the Army, the Navy, and industry were training their test pilots from the ground up.
Recognizing that the public perception of the swashbuckling, devil-may-care test pilot was at odds with the reality of flight tests, the Army sought to put recruits in the proper frame of mind.
The work of the accredited test pilot is not just a simple job of flying. The men selected for this work must meet certain specifications for an engineering background and adequate flying record. Picked men go through a rigid period of training and apprenticeship before reaching the top test pilot status. From the very first, they must understand that the serious business of flight testing is at all times a technically accurate procedure, frequently dull and unexciting.
The message was hammered home. This man's army was no place for pilots with delusions of grandeur.
Flight testing means thoroughness. More often, thoroughness at its dullest. Thoroughness that takes hours of precision flying. You can expect no thrilling exploits, no heroics, no public acclaim. Someday, when you have mastered the flying characteristics of many types of aircraft, have learned to cooperate with the flight test engineers, to render intelligent suggestions and decisions on design, function, and production, then you may be accepted as one of this group of specialists at Wright Field, known and respected as flight test pilots.
Flight test procedures were, in fact, being standardized, becoming more quantitative and exact. The clipboard and stopwatch became as familiar as the stick and rudder. New monitoring devices were employed. Film cameras recorded every gauge and dial for later analysis. Each test pilot trainee was sent aloft to perform carefully planned maneuvers with exactly the right equipment for the job. Every flyer could set out secure in the knowledge that nothing was left to chance. Pilots gained experience flying a wide range of flight profiles. Instruments were checked and the readings recorded at specific intervals. Precision was the watchword. Advanced training focused on defining the limits of an aircraft's performance. Pilots had to guide the ship through a disorienting series of spins and stalls, dives and climbs. Studying the data, the pilot would then be able to quantify the plane's performance. More difficult and dangerous procedures called for the pilot to deliberately force the plane into a spin, then attempt to recover. An intentional stall would make the plane plummet like a stone. Gut-wrenching maneuvers such as these tested the nerve of even the most confident trainee, but at the same time developed the essential skills of the professional test pilot. During the war, trained test pilots were in high demand, both within the military and throughout the aircraft industry. Each manufacturer employed its own staff of test pilots. Everything from pilots who tested each ship off the assembly line to those specialists whose job it was to coax a brand new airplane into the skies for the very first time.
Flight 4, this is Grumman Tower. You are cleared for takeoff.
Often the fate of an entire company, thousands of jobs and millions of dollars rested in the expert hands of these corporate test pilots. When that new ship took wing for the first time, it soared on the hopes and prayers of 1,000 hearts, every one of them watching breathlessly for the first sign of trouble. But more often than not, pilot and plane rewarded anxious spectators with a lofty display of aeronautic achievement. After the prototype proved airworthy, Further testing followed to explore the limits of the ship. Test pilots investigated stability and control characteristics, maximum speed, service ceiling, range, the things that made up the flight manual. Further investigation determined mean time between failure, maintenance man-hours, and other logistical and human factors. With aircraft production at an all-time high, the sheer number of planes rolling off the assembly line created increased demand for test pilots. Before the men in uniform could take delivery, each and every ship had to be tested. Vast numbers of newly hired company test pilots took the aircraft aloft, checking every control and component. This tremendous volume of work opened the doors for women test pilots across the country. When these professionals certified a ship fit for duty, it meant that almost immediately the plane was out the door and off to war. Wartime pressures led to a proliferation of unconventional designs. At times, the test pilots must have wondered what they had gotten themselves into. This bizarre bird, the Vought V-173 Flying Pancake, was designed to fly at both very high and very low airspeeds. Vought test pilots fluttered around in the Pancake throughout the war, gaining knowledge that would prove useful for subsequent developments in short takeoff and landing aircraft. But the Flying Pancake itself proved to be one of the many aviation oddities that only a test pilot would ever fly. The demand for test pilots had never been greater. From the fantastic to the fanciful, aircraft of all shapes and sizes flew off the drawing board as fast as manufacturers could find a test pilot. Combat-proven designs spawned a host of imitations. The XP-58 was an enlarged version of the successful P-38 Lightning. Similar thinking resulted in this twin-bodied Mustang, the F-82. The Ryan Dragonfly, small and lightweight, employed an adjustable airfoil to enable it to take off and land in the space of a few yards. From the smallest to the largest, test pilots put their training to work proving even the most incredible designs.
Largest plane and storm center of a congressional inquiry awaits tests at its dock in Long Beach, California. Builder of the monster, Howard Hughes, stormy petrel of aviation, surveys the 320-foot wing of the Colossus, whose weight is 200 tons and whose length is 200 feet. The air giant starts to move, driven by her 8 3,000-horsepower motors. For Mr. Hughes' surprise, as the enormous craft approaches her 95-mile-an-hour takeoff speed, the pilot lifts her onto the step and holds her there as she races through the choppy sea. And with the final drive of her engines, 200 tons are airborne, 5 months ahead of time. 70 feet off the water, she stays for a mile. $23 million worth of airplane has answered a lot of committee questions. It can fly.
Other experimental craft proved to be more successful. Aircraft builder Igor Sikorsky designed the world's first production helicopter and piloted many test flights himself. The helicopter was an idea whose time had come. Though rotary wing aircraft had been envisioned as far back as the Renaissance, a working prototype proved elusive until the late 1930s. In addition to Sikorsky, Bell Aircraft Corporation also conducted crucial research. Other manufacturers, both here and abroad, were making their own investigations. German test pilot Hanna Reich flew the FW-63 helicopter as early as 1936. Though this ship never went into production, Reich flew other craft that did. Famed as the first woman to pilot a glider over the Alps, Reich flight tested the Me-163 Comet, the world's first rocket-powered interceptor. The Comet was designed to zoom straight up, then glide back to Earth once the rocket burned out. Reich also tested a piloted version of the V-1 buzz bomb before the German surrender put an end to her test piloting career. But rockets weren't the only breakthrough. The big noise in aviation was jet power. America's first jet aircraft, the Bell XP-59A, made its inaugural flight from the hard-packed earth of Rogers Dry Lake in a secluded corner of the Mojave Desert near Muroc, California. Bell test pilot Bob Stanley flew the first American jet. With a top speed of only 390 miles per hour, the P-59 was no faster than its propeller-driven contemporaries, and its revolutionary jet engines had a life expectancy of a mere 5 hours. But the future was clear. Jet propulsion offered almost limitless potential for increased altitude and speed. The P-59 paved the way for the fighting jets that followed. Lockheed's F-80 Shooting Star, America's first production jet fighter. And the North American F-86 Sabre, mainstay of the U.S. Air Force in the Korean War. Jet technology was also incorporated into Northrop's family of flying wings. Under the guidance of the many new military test pilots, these exotic silhouettes rose from the desert base at Muroc, favored for its vast expanses of lakebed runway and year-round flying weather. Evolving from a propeller-driven single-seater into the multi-engine YB-49 jet bomber, the Flying Wing, with its high-efficiency, low-drag, aerodynamic design, seemed to be the shape of things to come.
The Flying Wing came to a tragic end. The giant YB-49 crashed to Earth, not far from here, taking with it its crew of 4, including pilot Glenn Edwards. In his memory and in honor of all test pilots and crewmen who paid the price for our progress, this rambling collection of desert runways and support buildings was renamed Edwards Air Force Base. From these wide open spaces, scientists and test pilots launched an unprecedented assault on higher and faster. The stars had never seemed so close. Yet many obstacles remained. With the advent of jet aircraft came the tantalizing possibility of supersonic flight. But was it possible? Could man and machine survive the tremendous forces required to exceed the speed of sound? Someone would have to seek the answers and set off to break the sound barrier.
To probe the problems of high-speed flight, aeronautic researchers envisioned a new class of aircraft, planes whose single purpose was an all-out assault on the sound barrier. These new ships bore the designation X, for experimental. But problems developed as the newer planes approached the speed of sound. High-speed flight caused a compression of the air, leading to airflow disruptions that adversely affected aircraft performance, sometimes with disastrous consequences. These shock waves led some experts to speculate that supersonic flight was a physical impossibility. Against this backdrop of uncertainty, Chuck Yeager prepared to climb aboard the bullet-shaped X-1 for a crack at the sound barrier. In final preparation for the flight, the plane was slung beneath the mothership while last-minute inspections were concluded. Nicknamed Glamorous Glennis in honor of Yeager's wife, the X-1 was ferried down the runway toward a date with history. Carried aloft in the belly of a B-29 to maximize available fuel, the X-1 was flown into position, 20,000 feet over the desert floor. Wriggling through the narrow bomb bay and into the cockpit, Yeager braced himself for launch. The plane dropped away, free-falling momentarily before ignition. The sturdy ship rocketed ahead. Tracking stations monitored the flight as all eyes focused on the tiny streak. With the double crack of the first sonic boom, Test pilot Chuck Yeager and the X-1 had smashed the sound barrier. Yeager's record-setting days were far from over. In a new fleet of X-planes, he and an exclusive group of test pilots conducted aeronautic research in a determined effort to push aviation faster, higher, farther. Approaching the very edge of space, military and civilian aviators returned from each flight, confident of their growing ability to reach new heights. On a bright September morning, a new rocket plane hit the hard-packed earth of Edwards Lake bed. A swarm of support personnel converged on the brand-new swept-wing X-2, eagerly rushing to welcome home its pilot. This had been no ordinary flight. Test pilot Ivan Kinchlow had attempted an unprecedented climb into the record books. Going all out for altitude, Kinchlow soared into the thinnest reaches of the atmosphere, where the Earth curved away beneath the blinding, unfiltered sunlight. Returning from more than 125,000 feet, Kinchlow was dubbed First of the Spacemen. Sadly, less than 2 years later, Kinchlow perished in a dreadful crash at Edwards. In the summer of 1956, the two-chambered rocket motor in the X-2 was prepped for the most demanding flight yet. On July 23rd, Pete Everest prepared to go all out for speed. If he could maintain a precise flight profile and attain maximum acceleration, the X-2 might race to unprecedented speeds. Readying himself for the critical task ahead, Everest climbed into the B-50 for the ride to the top. After separating from the mothership at 30,000 feet, Everest lit the fuse. The slender X-2 surged ahead, pressing him back against the seat. Everest poured it on, pushing the X-2 to the limit, straining to keep the ship on the optimum flight path. As he pushed over at 65,000 feet, the X-2 hit 1,900 miles per hour, Mach 2.87. And Pete Everest became the fastest man alive. But the X-2 met a disastrous fate. After hitting a top speed of more than Mach 3, Mel Abt found himself tumbling out of control. Little understood dynamic forces peculiar to very high-speed flight had conspired to create catastrophe. In these actual photographs from the last flight of the X-2, pilot Abt can be seen struggling to right his ship moments before he elected to punch out. Unfortunately, Abt failed to survive the violent stress of high-velocity ejection. But the sacrifice of this first Mach 3 test pilot made possible improvements in supersonic safety. By this time, a test pilot's duties were not limited to flying the experimental ships. Flight testing was a group effort. These highly trained aviators functioned as a unit, supporting one another in a variety of roles. On the maiden voyage of the X-3 Stiletto, Douglas test pilot Bill Bridgman could count on the assistance of the entire mission team, including Chuck Yeager, flying alongside in the F-86 chase plane.
About 10 degrees. Brakes power just a
The success of its first flight notwithstanding, the X-3 never lived up to expectations. Limited by engines less powerful than designed, the X-3 was soon relegated to the Curiosity section of the Air Force Museum. However, the information gained from these high-altitude research planes provided valuable data for the new generation of fighting aircraft being introduced. The North American F-100 Super Sabre was the first supersonic fighter in the U.S. inventory. George Wheaties Welch, North American test pilot, flew the first flights. And the F-104 Starfighter, guided on its maiden voyage by Lockheed test pilot Tony LeVere, was the first production fighter capable of Mach 2. X-Series flight test also made possible that famous high flyer, the Lockheed U-2, veteran spy plane of the Cold War, capable of soaring over enemy defenses at more than 70,000 feet. But the quest for higher and faster didn't stop here. North American Corporation's X-15 test vehicle was to prove the most successful of the X-Series research planes. In the tradition of test pilots like Lindbergh and the Wrights, North American test pilot Scott Crossfield helped design and build the X-15 and flew the first missions himself. Together with NASA test pilot Joe Walker and Air Force Captain Robert White, Crossfield and his fellow flyers were subjected to rigorous physical and technical training, the equal of later astronaut indoctrination programs. Experience with simulators and centrifuge training prepared these test pilots for the difficulties that lay ahead. On the fourth mission, an engine malfunction led to an emergency landing that buckled the X-15 fuselage. Pilot Scott Crossfield emerged unscathed, though repairs to the plane took 4 months. The arrival of a more powerful throttle-controlled rocket engine generated new excitement. With Crossfield in the cockpit, the reconfigured X-15 underwent a series of routine integration checks. A faulty relief valve touched off a catastrophic explosion that virtually destroyed the X-15. Fortunately for Crossfield, the blast flung the forward section away from the flames, while the thermal insulation shielded the cockpit from the intense heat. Shaken but unharmed, Crossfield was soon able to fly again. This flight was aborted and a frantic effort made to jettison the remaining fuel before the X-15 slammed to Earth. Overloaded on touchdown, the landing gear collapsed, resulting in this near-fatal crash. Undaunted by these setbacks, the X-15 crew marched ahead. Walker set a new speed record.
60 at 165.
Quarterback area, Joe.
Roger.
Gyro good.
Your boy. Push over.
Go.
Burn out. Plus 3 plus.
You made it.
White followed with a new mark for high-altitude flight.
Pull up. Roger. Right on the track. Your angle looks good, Bob. Sure going up. Past 9. Going through 11 now. Burn out. Out now at coming 12 now. Got 12.6 and 13. Very sensitive. That's still good. This is fantastic up here.
And the X-15 continued to leapfrog higher and faster, eventually exceeding Mach 6 and flying higher than 350,000 feet. The pioneering work of test pilots Crossfield, Walker, and White received public acclaim reminiscent of the early days of flight. Their trailblazing efforts made possible incredible aeronautical achievements, such as the Mach 3 Plus SR-71 Blackbird. Its titanium construction and special heat-resistant components owe much to the research provided by the X series of aircraft. As the flight test program expanded, a select crew of military and civilian test pilots joined the X-15 team. Among them, a young NASA flyer named Neil Armstrong. The latest in the long history of outstanding test pilots, Armstrong, whose skill, resourcefulness, and presence of mind prompted his selection to the astronaut corps, relied on his flight test experience to see him through many difficult situations. Whether piloting the most sophisticated rocket ship or this simple paraglider escape vehicle, Armstrong's flying skills were often taxed. On his first flight into space, Armstrong's ingenuity saved the day when he switched to manual control to overcome a balky thruster that threatened to destroy his Gemini capsule. Exemplary judgment prevailed in this aborted practice run in the lunar landing training vehicle. And then, in July of 1969, Armstrong led the crew of Apollo 11 on a trip to the moon. It was a journey that would require the full measure of courage and skill. In the tradition of the greatest test pilots, Armstrong carried with him man's indomitable need to explore and guided his untried ship toward a new frontier.
Forward. Forward. Head. Tango. Looking good, over. Roger, copy. I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.
From Kitty Hawk to the Sea of Tranquility, test pilots have led the way. They've overcome gravity, survived the highest altitudes, smashed the speed of sound, and left Earth itself far behind. And the quest continues. Setting forth day after day, brave men and women touch the limits of understanding in extraordinary machines. The space shuttle, the X-29, or this, B-1. The work is demanding, the risks great, and the glory, if any, fleeting. With each success comes a new challenge, and even the failures lead to new heights. For in a world of limitless possibilities, there are no barriers for those who refuse to accept them. The test pilots.